is Abongile Mbusha from Ulwazi High School. Welcome to the ECDoE broadcast studio. We are having our special shout out to Sivuile Machawa from Motherwell High and Ongeziwe Kyali from Newell High School. Continue, guys, to keep it on shout out. On recap on our first scenario, on the first scenario here, we had now an object which is dropped from a certain height moving downwards then, okay? And also on the second scenario, the ball was thrown from a certain height, but on both those scenarios then, the object was only going on the same direction, which is downwards, okay? So now on this lesson now, we'll focus now on the object that is going now on them both direction now, that is going upwards, then also is going to go back downwards then, okay? So let's look now. Okay, so if we're having now an object here that is being thrown from the ground, okay? So if it is being thrown from the ground, remember the velocity here, it cannot be zero. It cannot be equal to zero. Now, any object from the ground, it must be thrown in order for it now to move upward, means that now it must be thrown with a velocity that is non-zero, with a velocity that is non-zero, okay? So now, means that now you have to throw this ball with a certain velocity, or make an example here, that is the initial velocity then, maybe let me use red, okay? V, let's say, is given as 5 meters per second upwards. We throw a ball with that velocity upwards. So if we're throwing that ball with that velocity upwards here, okay, so as it goes up here, the velocity decreases, okay? As it goes up, the velocity decreases then, okay? So the reason is that the velocity, as it goes up, is upwards. Now that the velocity is a vector. But now the acceleration due to gravity is going downwards. So the velocity and the acceleration here now, they are moving now in opposite direction then. So now, hence now the object now is losing its kinetic energy. That now as it goes down is what is slowing? Is slowing down, okay? So now as our object is moving upwards then, that now the velocity then decreases here, okay? So if it decreases now, it decreases until at maximum height then it reaches zero. The velocity at maximum height then is going to be always zero, okay? But now you must note that the velocity at maximum height is zero, but the acceleration due to gravity is always 9.8 meters downwards, okay? Now, with the velocity from the maximum height here, when the velocity is zero, as the ball changes its direction now, moving downwards now, then the velocity now will start to increase now, okay? From zero until it's back now to the point of projection. So if now it is back to the point of projection, that now is going to increase from zero up until it reaches the point of projection. Then when it comes to the point of projection, then it's going to come with the same velocity as this one, but now in an opposite direction here. That means now the final velocity there is going to give us negative 5 meters per second. Now that now is moving downwards. That means now on this scenario here, up is taken as positive here, because now this initial velocity, when it is the object was moving upwards, the velocity was positive. But now once it moves downwards, then the velocity is what is named is negative. So now once the object now is thrown, then it goes back to the same position it was thrown from. Then the velocity then are going to be equal but in opposite direction there, because now the motion before it was upward, then the motion after it was downwards here, okay? So now as the ball move up, then the velocity decreases, but as the ball move this side moving downwards, then the velocity increases from 0 to, that is that amount of negative or to 5 meters per second downwards, okay? Then now go into the issue of acceleration. So now the acceleration here, this, remember acceleration here is a constant and is always going in this direction, that is downwards. Whether the object is going up or the object is going downwards, or the object is at maximum height, then still our G is given as 9.8 meters per second squared here. At any position, whether it's going up, it don't care if it's going up or down, or is it its maximum height, still you'll find your acceleration to be 9.8 meters downwards. It will be the 9.8 meters downwards there. Okay. Okay. Let's move now to another slide, so that now we can put that one into practicality, so that we see what we're talking about. Now. Okay. Now let's look at on this one. What are we having here? So that now. Okay, so on this one here, that question 3, ball A there is projected vertically upwards with a velocity of 10 meters from the ground, as shown in the diagram below. So this is our diagram here. Okay, then if we were to look at the concept now to be addressed on this topic here, or on this scenario, then we must be able now to choose a direction. That's very much a vital thing. Remember, the direction, it must not be the same as to your friend. In that now you must choose your own direction that is now is beneficial to you. And on this case now, remember, everything that is going up will go down. That means now eventually. So that means now we are going to have now two directions now on this case. So we must be careful as to check that the direction then for that particular position that is you'll be referring to. Okay, so now that now our initial is moving upwards, now let's take now that is up as positive. Let's take up as positive. So everything that is going to go down is going to be negative. Okay, so now if we took up as positive, let's look now on this guy. So that means now we are done with this one. Then now let's look now at the acceleration at maximum height. So the acceleration now at maximum height, now as you know, this ball is going to go upwards, then until it reaches the maximum height, then it goes downwards then. It goes downwards from the same point it was projected. But now at maximum height then, our acceleration at this position here, G is 9.8 meters per second squared downwards there every time at this position here, at any position in the projectile, then acceleration due to gravity is this one. Okay, but now that you've chosen now the direction, then that is up, that now as positive. So this one is supposed to be negative 9.8 in your substitution here. Okay, but now you've alluded that now it is going downwards there. So it's 9.8 meters per second downwards now. Okay. Now, I think now we're done also with this part here. We're done with that one. Okay, sorry. We're about to enter this one. The time to reach the maximum height. So that now we need to calculate the time to reach the maximum height. Now, let's go to the data. What do we know? What do we know first so far? Now we are given our guy. We're given our guy here, that is our initial velocity. We're given our initial velocity here as to be 10 meters per second. So that means now our initial here is given as 10 meters per second. Because it's going upwards, so it is positive. Okay? Then again, when we go to the maximum height, we do know that now at maximum height the velocity is equal to 0. So now we know the final velocity. The final velocity 0 is 0 meters per second. There. Okay. Then again, we also know that our gravitational acceleration here. Remember, the g is always going downwards. Whether the object is going upwards, then G is always going downwards. Now, our G is supposed to be negative 9,8 meters per second squared. Now, we know the three things now. So that one is sufficient now for us as to be able to choose on one of the equations of motion that will be now suitable for this, the information that we're having. Now, what do we want here? We want the time. We want the time now, okay? So now, if we want the time, the information that we're having now is sufficient for us to choose the equation of motion that is given as V final, which is equal to V initial plus AT, okay? Then the final velocity is 0, which is equal to the initial velocity is given as 10 plus into negative 9,8 T, 9,8 T, okay? Then now from here we're solving for T, then we transpose 10 to the other side, so it's going to be negative 10, which will be equal to negative 9,8 T, okay? Then we divide both sides by 9,8, both sides by 9,8 here. Then we are going to get, that is our T to be, okay, in punching of calculator. Then our T is going to give us 1,02 seconds, okay? Then our T is going to give us now 1,02 seconds here, okay? Then now, okay, that's our time. So our time, okay, we're done with that guy. Then now let's go to the maximum height reached by the object. That means now we want now the height, now that is reached by our object here. So now if we want the height here, now we're having the sufficient information. We can calculate again the delta y using the equation V initial squared plus 2a delta y. You can calculate that one using that because you have the velocities there and you also have the acceleration, okay? Also, you can calculate using delta y is equal to V initial T plus half a T squared, okay? Also that one because you have the initial velocity, then you have the acceleration, you have time, okay? Also, you can calculate that one using the equation, say, that is V initial plus V final divided by 2, all multiplied by delta T. Okay, so you choose the one that is going to be suitable for you, okay? So on this one, let us choose the last one. Let's choose the last one. In terms of calculating that. That is delta y is given as V initial plus V final divided by 2 multiplied by delta T or T. Then now let's see here. Now our initial is given as 10, then our final is given as 0. That is now from this particular point to that particular point there, okay? So that now we're taking that section here. Then now divided by 2, multiply by the time from here up until it reaches the maximum height here. So the time at maximum height is given as 1,02 seconds here, okay? So now if we are to punch a calculator from that, then you are going to get now that delta y there to be 5,10 meters. 5,10 meters. That means now, okay, so that's going to be our height. From here. That is 5 meters. 5 meters from the ground until it reaches the maximum height. Okay. So now check. We're done with that. Then now we'll go to now the time to come back from the point of projection. The time to come back from the point of projection. Okay. Now, let's look on this one. Let's look on this one carefully. Okay, so now remember, when the object was from the ground, then it goes up until the maximum height there. Okay, so now from the maximum height until it reaches the ground again, then this ball now travels now the same distance on this case. Okay, so it traveled the same distance or the same height, that is 5 meters from this particular point. If I can point A, then this is point B. From point A to point B, it travels, that is 5 meters. Okay, learners, now let's go to the time to come back from to point of projection there. So now, that means now from here, want now the time from here to here. So we've calculated the time from this point A, let's say, to point B. We've calculated that time, then we got 1,02 seconds there. Okay, then now from point B to point C. Okay, remember, this object here is moving from point A to point B. Is moving the same height as from point B to point C. The same height, and also is under the same gravitational acceleration here, that is meters per second squared here. Okay, so now if it's under the same gravitational acceleration here, you would also remember that now if now the object is thrown from this point, then it comes back to the same point here. The velocity here, it was 10, then it decreases up until it reaches 0. That is at maximum height. Then now from maximum height, it increases from 0 up until it reaches again, that is negative 10 from the point of projection here. Okay, so now that means now the time taken from the ground to the maximum height is the same as the time taken from the maximum height to the ground there. Okay, so that means now if now you want to know the time for the entire journey, so that means now you can calculate now the time to maximum height, then you multiply that time by 2, then you're going to get the time for the entire journey there. Okay, so that means now for this point here, the time to come back from the point of projection here is the same as the time it took from the point of projection to the maximum height there. So it's the same time, the one that we've calculated. Okay, then now let's quickly go to the graphs. So now we're on this one, so this one check. Now want to now to draw a velocity versus time graph. So on velocity versus time graph, so now this one is positive 10, this one is negative 10. Okay, now we're having V versus time. Then here we're having time in seconds. Okay, so now let's look here. Now we took upward as positive. Remember. So now that means now as the ball was moving from the ground, the velocity was positive because what is going upwards. So that means now our graph we're expecting to start this side. Okay, then now from maximum height as it goes downwards, now then our graph we're expecting now to be on the negative side because now it is going downwards, and down now is supposed to be negative if we took upward as what is as positive. So now the graph, our graph now supposed to go like that. Okay, sorry, it's supposed to go like that, the shape of that graph. Okay, now you'll remember that now from 10, then it goes downwards now to what? To 0. So that means now the velocity is decreasing from 10 to 0 because the object is moving upwards. The velocity decreases as the object moves upwards because the velocity and the force that is acting there, they are in opposite direction. So the velocity is decreasing up until it reaches what? 0. Okay, so now for this one, now you can note that at this time axis here, then that's going to be your maximum height. That is now your x-intercept now on this graph. That's going to represent your what? Your maximum height there, because every time on this line, your velocity will give you 0. Okay, then now from 0, then it increases now up until to -10. That means now we're on this part, then it goes downwards there. So as the object goes downwards, then the velocity increases here. The velocity increases there. So don't go with the sense of that, but now the object is moving upwards, so your graph's supposed to move upwards. No. Means that now your graph is supposed to go what's happening to the velocity. So the velocity as it goes up, the velocity is decreasing. So you're going to get a nice straight line like that, okay? And also you must look at this area. The area here is supposed to be also equal to the area here. For an object that is thrown from the same position, then it comes back to the same position here, okay? So now, what does this area mean there from velocity versus time graph? Then they are going to represent this height here. You'll remember that now the distance from the ground to the maximum height is equal to the distance from the maximum height to the ground. So hence now this area is supposed to be what? To be equal, okay? So now that's a graph for velocity versus time graph, okay? Then now, I think so the time here was given as 0,02, then multiply that by 2, then it's going to be 2,04, okay? It's going to be 2,04 there. That is if I were to indicate the time. If I were to indicate the time, okay? Then now from there, let's move to drawing of position versus time graph. So the position versus time graph here will have something like that. So if I have in something like that there, then the position, it was thrown from the ground, then also it returned to the ground. So if we take now the ground as 0 reference, okay? So this one's going to position in meters, then this one's going to be the time in seconds here, then this is position versus time graph. This is position versus time graph. This is position versus time graph there. So it's supposed now to give a nice graph like that, okay? Then now we'll go to, so check, then we'll go to the last one, the acceleration versus time graph. Let me use this one here, acceleration versus time graph here. This is 0. This is A versus T, acceleration versus time graph, okay? Then now we took upward as positive, okay? So now that we took upward as positive, 9,8 here, 9,8, here is negative 9,8, okay? So it's negative 9,8. So this is acceleration in meters per second squared. Now, on this one, remember, yes, we took upward as positive. So acceleration is always going downwards. So that means now our graph now it's supposed to be downward straight like that. So it's supposed to be downward straight like that. Okay. Then now, okay, for the last one, if now an object here, this is now we can recall as this one now as a matter graph. This one. Sorry, let me go back. Let me, okay, let me draw that again. Okay, so we had that graph, here. Okay, so now this one now we can point this one as our matter graph now from mathematics. From the point of mathematics, if you can note here, okay, so this side here, this one's more or less the same as a line of symmetry here that cuts the graph now into 2 equal halves. Then now this side is more or less the same as that side then. More, and also on velocity versus time graph, this side is also equal to that side there in their areas, okay? So now from here, this one is for an object that is from the ground, then returns to that point of projection, okay? So if an object then, it is thrown at a certain height, that is now from those scenarios, that is we just thought of, that is scenario number 1 and scenario number 2, whereby the object was dropped from the certain height and also the object was thrown from a certain height, okay? So now, if you are to draw this graph now for them, okay? So now you need to shift now this line, that is your position versus, that is now your the y-axis now towards the right now, if you want to attain now the shape of the graph for an object that is thrown that is thrown from a height or that is dropped from a height, okay? So now you need to shift this line towards the right, okay? So if the object is thrown upwards at the top of the building, then you shift this line to the right, then this line is going to be at this position now, this line. So that means now the object is thrown now upwards. So if it's thrown upwards, now the shape of your position versus time graph is going to look like this. The shape of position versus time graph is going to look like this now. If that is, it is thrown upwards from a certain height, okay? Then now if that ball is thrown downwards from a certain height, then again, you shift that blue line. Now is going to be the black one on this side now. So that means now your graph is going to be on this side. Then now the shape is going to be given as that shape now of position versus time graph for a ball that is thrown downwards. For a ball that is thrown downwards from a certain height then. From a certain height there. So that's what you're supposed to get there. Okay? Then also, on the position versus time graph one, if now the object is thrown from a certain height, so if it's thrown from a certain height, then again you shift this line towards the right. So now let's say the ball is thrown upwards from a certain height. So definitely it's going to move a little bit upwards. Then it goes down to the ground, then past the point of projection now. So now that case now, we are going to have now a graph. This line, if you shift this line towards the right, then now that means now this line of y-axis there is going to start this out. Then now you're going to have now a shape of this nature. That means now look at the area now on this one and that area now. So this area here is small because now it goes upward a little bit. Then this area is big because it's from the maximum height up until the ground. So now it's going to give you a nice shape like that. That is your graph. A nice shape like that. That means now you shift that graph towards that. See about them? Then now from there, if the ball is thrown downwards, or let's say that the ball is dropped downwards. So if the ball is dropped downwards from a certain from the certain height, then you shift further that line again towards the right. Then now your line there of the y-axis there is going to sit there. Then now you're going to have now a graph like that. So that means now your graph now is going to be only this straight line like that. And that now the initial velocity is what? Is 0 at that particular position there. It's going to be 0 at that particular position, okay? It's going to be 0. Oh, sorry about that. So that means now... Okay. So now the velocity now is going to be 0 since it was dropped from here. Then now it goes straight downwards then. Okay, so as you can see, the velocity is what is increasing as you go down. Okay, so that's the shape that you are going to be given now, or that you are going to get if the ball is dropped from a certain height there. Then the graph is supposed to look like that, or it's supposed to look like that, depending now on them on the direction that you've chosen as positive or as negative. So it's up to you. That now these are the shape that now you're supposed to get. Then now as for acceleration, then the acceleration it will also look like that. Okay. We've come to the end of our lesson. You can leave your question on comments. Don't forget to leave the name of your school so that you can shout out. Please share, recommend, subscribe on YouTube, on our YouTube channel. We'll see you on the next lesson.